Hello everyone. Once again, I would like to welcome all the viewers and especially the class 10 students to this online class conducted by State Council of Science, Technology and Environment. So for today, I will continue my lecture on the chapter of surface area and volume. So today I'm going to solve a problem which involves changing of one object to the other. And here is important point to note that when one object is changed to the other, we should note that volume of the first object is equal to the volume of the second object. So here we're going to solve that problem. So let us start. So the question is a cone of height 20 cm and radius of base is 5 cm. So here is a cone of height 20 cm and radius 5 cm. It's made of modeling clay. This cone is made of clay. A child reshaped it in the form of a sphere. So this child, he changed the shape of cone into a sphere. And here I name the sphere. I name the radius as capital R because this radius and this radius might not be the same. So I name that by different symbol. So solution is given to us. Height of the cone denoted by h is equal to 20 cm and radius of the cone denoted by small r is given by 5 cm and let r, capital R, be the radius of the sphere. So when the cone is reshaped into a sphere, we get that volume of the cone is equal to the volume of the sphere. Right? So formula of volume of the cone is given by 1 by 3 pi r square h, and volume of the sphere is 4 by 3 pi into radius cube, but then the radius of the sphere is capital R. So here I'm going to find out the value of capital R. Here 3 and 3 cancel, pi and pi cancel. So we left out with r squared into h. So r is given to us, it is given by 5 squared into. So we left out with r squared into h, and r is 5 whole thing squared into, and h is 20, which is equal to, here we left out with 4r cubed. So 4, and we have to find out the value of r. So r is unknown, right? So we'll bring this 4 to this side, cross multiply. So we left out, we get here 20 by 4 equal r cubed, and 4 and 20 cancel, get here 5. So here we get 5 squared into 5. That is 5 cube, which is equal to r cube. So we can write r cube equal 5 cube. Take cube root both sides. Is equal to cube root of 5 cube. Cube root of r cube is r only, and cube root of 5 cube is 5 centimeter. But then the question is, we have to find the diameter of the sphere. So diameter of sphere is equal twice r, and twice into 5, which is equal to 10 centimeter. So this is the diameter of the sphere. So here I'm going to discuss a new topic, is frustum. So by definition, it is if a right circular cone is cut off by a plane parallel to its base, then the portion between the base and the cutting plane is called a frustum. So here I have cone with me, and this plane, I cut this cone in such a way that this plane is parallel to this base, right? So I cut these two objects, right? So this is still cone, so I will exclude it. So remaining is this object. So this is called the frustum, right? So this is a frustum. So as you can see, in this frustum there are two circular bases, right? So in every circular base there is a radius, right? So I name this as, this is the radius, so I name it by R1, and the other base, here is the radius, I name it by R2. So as you can see, this base is much smaller than this base, so the radius are different. I name the bigger radius as R1 and smaller radius as R2. And also this frustum has a height. How to measure the height of this frustum? So the height of frustum is measured by a line which is perpendicular to both the radius, which is perpendicular to R1 and R2. So this is the line which is perpendicular to both the radius R1 and R2. Also we have the slant height, which is this part, which is denoted by L. So now I am going to introduce the formulas of finding curved surface area, the total surface area, and the volume of frustum. So here, curved surface area of a frustum is given by pi R1 plus R2 into L, and total surface area of a frustum is given by the curved surface area plus area of the two bases, and curved surface area is this much, pi R1 plus R2 into L, plus there are two bases of radius R1 and radius R2. So the first one is pi R1 square plus pi R2 square, and pi is common to all the quantities, so I take common pi, so we left out with pi R1 plus R2 into L plus R1 square plus R2 square. So So this is the total surface area of a frustum. And the last one is the volume. Volume of a frustum is given by 1/3 into pi into R1 square plus R1 into R2 plus R2 square into H. So these are the formulas related to frustum. So here I'm going to solve one question from this topic, frustum. So here is a problem. A metallic bucket open at the top of height 24 centimeter is in the form of a frustum. So this bucket is in the form of a frustum, which is open from this part. The radii of whose lower and upper circular ends are 7 centimeter and 14 centimeter. So the radius of the upper circular base is 14 and the radius of the lower circular base is R2, which is equal to 7 centimeter. So the question is, find the volume of water which can completely fill the bucket. So let us start the solution. Given radii of the frustum are R1 equal to 14 centimeter and R2 equal to 7 centimeter, and also given to us height of the frustum is the height of frustum is H, given by 24 centimeter, right? So we have to find the volume of water which can completely fill the bucket. So in order to find the volume of water, we first in order to find the volume of water that can fill in the bucket, we have to find the volume of this frustum. So volume of water that will completely fill the bucket is equal to the volume of the frustum, which is given by 1/3 into pi into R1 square plus R1 into R2 plus R2 square into H. So R1, R2 is known to us, and also W of H. 1/3 into pi is 22/7. R1 is 7, which is R1 is 14. It is 14 square plus 14, and R2 is 7 plus 7 square into H. H is 24. So 3 and 24 get cancelled, which is equal to 8 into 22/7. 14 square is 196 plus 14 into 7 is 98 plus 49. 7 square is 49. So 8 into 22/7. If you add this one, we will get 343. So cancel 7 and 343, we get 49. So if you multiply 8 into 22 into 49, we will get 8,624, and the unit is centimeter cube. So the volume of this water that can be filled in this bucket is this much. So students, this is the only one problem I have done from the topic of Frustum, and also this is the last topic of this chapter, and I hope you have understood a lot that I've been lectured in during these previous classes. So only these few words. Thank you so much.